So this is nothing but the properties of electromagnetic waves. So we were discussing so far all these properties, but I have cumulatively given you it as total properties of electromagnetic waves. Okay. See the first property. It is produced by accelerated charges. As we were discussing, we were oscillating the charge, or we call them as accelerated charges, right? So the source of electromagnetic waves always is going to be accelerated charge, and it doesn't require any material medium for propagation. We were discussing that it is going to be traveling in vacuum with speed of light. Okay, so it doesn't require any material medium. It is not like sound. Okay, it's light. And the directions of oscillations of electric and magnetic fields are perpendicular to the direction of propagation, right? So x and y will be, if it is going to be the magnitude of electric and magnetic fields, then the z direction is going to be along the direction of propagation. Okay, so if a wave is going to propagate like this, which is going to be mutually perpendicular to the both the magnitudes, and if the direction of propagation is mutually perpendicular to both, we call those type of waves as transverse. Okay, so electromagnetic waves are transverse in nature. Okay, and then electric and magnetic fields are in phase, because we saw two equations. Ex is equal to E naught sine kz minus omega t. Likewise, By is equal to B naught sine kz minus omega t. So they both are in phase. Correct? So there is no any phase differences. So we call both are going to be in phase. Correct? Yes. And then it travels with speed of light. So the speed of light is 3 into 10 power 8 meter per second. Right? And then electromagnetic waves are not deflected by electric and magnetic fields. So electromagnetic waves cannot be deflected. What it means is, so if I have electric field, if I pass light, will it get deflected? No. If I have a magnetic field, if I pass a light through it, will it get deflected? No. So electric and magnetic fields are not going to deflect this electromagnetic waves, or otherwise vice versa. Electromagnetic waves are not going to get deflected by electric and magnetic fields. Okay, and then they obey principle of superposition. We were discussing that. So which shows the properties of reflection, refraction, interference, diffraction, and polarization. So the next two chapters we are going to deal in detail on these topics: reflection, refraction, interference, diffraction, polarization. Okay, so this is all about your ray optics and wave optics. Okay, and then electric field of electromagnetic waves are responsible for optics effect. That's why we call the electric field as what? Light vector. Correct? We normally call this as light vector because it is going to be responsible for light. Why? The magnitude of electric field is going to be very much greater than that of magnitude of magnetic field. So you can suppress the magnetic field. Always remember, phase the same, magnitude is not going to be same. Okay, so the electric and magnetic fields are going to have same phase, but their magnitude might differ, in which electric field magnitude is going to be responsible for light or optics effect of an electromagnetic wave. Okay, so these are the basic properties of electromagnetic waves. Is that clear? Do you have any doubts? No?